Hey everybody. So I've built this little house builder up a little, and you know, it's got some good points to it, but it's got a couple of issues. The issues are that it contains a metric crap ton of things. And this is only with the outermost layer filled in. I mean, I can go ahead and start to fill in inner layers all day and night too. So it's seriously something that could go, you know, hundreds or thousands of meshes. It would be a total mess. You have any idea how slow things would run if we just tossed 1,000 meshes into the scene every time we wanted to show a house? No, we have to combine these meshes. So that's what we're going to do. I'm going to teach you how to combine meshes. This is a little advanced, but I think that it's not too advanced. I think you'll be able to understand it. And once you know how to do it, you won't ever be confused again. It's very, very straightforward once you know how it works. First things first, we're going to need a thing to put all of our stuff in. Create empty, not in there, out here, silly. Put it at 0, 0, 0, and 0. Call it house. Oh, it's over here. That's not really where we want it. Let's put it, yeah, there we are, house. And let's drop these guys inside. There we are. So now we'll be able to tell that this house contains this stuff. And that's important because what if we created two houses? We would want them to stay separate. We don't want to combine every house into one mesh. We want to combine each house into its own mesh. So, oh, I deleted the wrong thing. Bring that back. There we are. What else do we want to do here? Well, we want to create a script. Call it a mesh combiner. Mesh combiner. And we'll drop it on that house. Come on. There we are. So what does that mesh combiner actually do? Well, what we have is a lot of meshes, and we want to turn them into a single mesh. Sounds easy enough, right? No problem. Well, that means that we're going to have a mesh at the end, and we're going to want to be able to show the mesh at the end. How does showing meshes work? Well, if we look here, this is a mesh that's being shown. It's got a mesh renderer, and it's got a mesh filter, and the mesh is all the way down here. So we kind of got a lot of steps here. We've got to have a mesh renderer, we've got to have a mesh filter, and we've got to fill the mesh into the mesh filter. All right. Mesh renderer, mesh filter. There we go. We just need to fill this part in, right? We just need to make that our house. All the rest of the meshes, we'll put them in right here, okay? That's fine. No biggie. We got it covered. We got it covered. So, how do we get started? Well, we need to actually make it so that we can find all of our child meshes. We've got to make sure that we can combine them all. But first things first, we've got to make sure that we can run. When you are creating something that's supposed to run in edit mode, the first thing you should probably do is create an editor. Just because this is a good time to do it. It's a good way to get your mind settled, and you're going to want to try and step around it, and that'll get you in trouble later. So it's much, much better if we just do it right now, right up front. How do we do this? Using Unity Editor. Mesh Combiner Editor is an editor, and it's a custom editor type of Mesh Combiner. Custom editor, no problem. So we can use this custom editor in a lot of ways. One thing we can do is we can make it so that when you select it, over here the button will show up and there'll be a button we can press to run it. Another option is to do the exact same thing we've done with everyone else and create a button we click in scene view. Because we've done it a lot of times already, it's kind of what we are doing. So we might as well go ahead and do it the same way everywhere. So there's a risk when you adopt code. Rather than trying to, you know, control find, switch, it's better to just delete all of the things that could possibly go wrong. It's better to delete all of the references to the other class because they don't really have that much in common. We don't want to cause any problems by refactoring incorrectly. So, we're going to refactor correctly. We're going to go ahead and erase it and start over. It's not very much code, so we'll just do it from scratch. Mesh combiner, MC equals target as mesh combiner. What are we passing handles.button? A position. MC.transform.position, but that's going to be at the bottom of the house. So let's go ahead and just move it up some. 5 meters should be enough, at least for now. Direction, quaternion dot look rotation vector 3 dot up. All right, so that's a direction. It doesn't really matter what the direction is. Size, pick size, and let's make it a cylinder. Now, if you're mystified about all this, I covered it last episode or the episode before, and it's pretty straightforward. We can just go ahead and say mc.combineMeshes. What do you mean that function doesn't exist? Oh, right, we didn't make any functions yet. Public void combine meshes. Debug.log name plus, no, why is that? Name plus is combining meshes. Right, easy enough, no errors, got it going, it's all working. House, there it is, click it. Combining meshes. All right, we're ready, we're on our way. What's next? What are we gonna do? All right, so what do we need to do? We need to find all of the meshes in our children. But the meshes aren't just floating free. We have to find these mesh filters. We have to track down the mesh filter in order to be able to find the mesh. That's no problem. Let's go ahead and say mesh filter, all of them, equals get components in children mesh filter. I forgot to name it. Filters. There we are. So now we are getting all of the mesh filters that we have inside of us. And we'll just go ahead and change this to actually give us that length. "60 meshes. That's a lot. And it could be a lot more. The insides are barren. We definitely need to combine these. 60 meshes is way too many. So how do we do that? Well, we need a place to put them. We need a mesh that we can stick all of these meshes in. We need to have a final mesh. Boom, we have a final mesh. So how do we move them from there into here? Well, first off, let's do a little bit of work at the end here, because what do we want to do with this final mesh? The final mesh has to be displayed, right? So we have to get our mesh filter and display it. So get component mesh filter dot shared mesh equals final mesh. Shared mesh, what does that mean? Mesh filters have two variables. They look the same if you're using the sidebar editor, the inspector, but they're very different. The shared mesh is basically the editor mesh. It's the asset mesh. Whereas the lowercase mesh is the one that it gets if you change something or have it at runtime in various ways. You never want to reference you never want to do this in editor mode. In editor mode, this will always cause problems because it'll make the system create a new mesh that's an exact duplicate of the shared mesh, which is just not what you want, right? We don't want a lot of extra duplicates. The whole point of this is to get rid of all the duplicates, right? So always just reference shared mesh if you can get away with it. And if you're not sure whether you need to reference shared mesh or mesh, it's probably shared mesh, even in play mode. So we have created the final mesh. We've set the final mesh. There's a lot of stuff we've forgotten to do in the middle here. Well, for int a equals 0, a is less than filters.length a++, right? Now what? Well, we need to take each individual mesh, but what are we doing with them? Oh my gosh. Oh, what are we doing? Well, the final mesh might hold the key, right? We want to put all of them in the final mesh. There's got to be a function for doing that. Add blend shape, frame, clear, colors, combine meshes, get blend shape. Wait. Yeah, there's a function for it. Okay. Combine meshes. Combine instance array? What the heck is a combine instance? Let's just create it. See what happens. Combine instance combiners equals new combine instance. I almost guarantee you we're going to need it to be the same length as the filters. There we are. it's clear that it's expecting one combine instance for each of these mesh filters. Why? Let's find out. Combiners A dot, well, it's certainly pretty simple. Mesh, submesh index, and transform. Let's start with the easy one. We're not using submeshes. Combiners A dot mesh. Well, that's easy too. We want to have it be the filters A dot shared mesh, right? Mesh. So combiners A dot transform. What's this? Well, let's take a quick look. We've told it to use a mesh, but the funny thing about this house is there's only like 5 meshes. This mesh and 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 this one and this one and this one. They're all the same mesh. And this mesh and this mesh and this mesh are all the same mesh. So we're passing it like a lot of the same thing over and over and over. What matters is where the mesh is located in our final mesh. So we say, yeah, we've got this wall mesh here. We want you to put 18 instances of this wall mesh into our final mesh, but each of these will have to be rotated and offset and put in a specific location. We've already done that. Look, here in the scene view, it's been rotated, it's been put in the right position. That is correct. Alright, so we just pass it the transform, right? Combiners A.transform equals filters A.transform. Why is it complaining? Well, the problem is that it doesn't know where you're referencing it from. It knows exactly how far this mesh has been rotated because it's got the transform attached to it and how far it's been moved and all that stuff, but it doesn't know where you're referencing that from. Are we talking about how far it's been moved and rotated from its parent object, or from its parent's parent, or from its parent's 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 parent, or from its parent's 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 parent? So you have to tell it exactly where you want it to be in the final mesh. Fortunately, it's not that hard at all. There is, in fact, a function for it. Local to world matrix. There it is. Matrix 4x4 and matrix 4x4. So that's all we need to do. We're saying wherever it's located in the real world, that's where we want it in the mesh. Okay? Done. And then we combine the meshes, and let's see how well this works. Yeah, select the house, and where is our button? We did have a button, right? Oh, I selected the wall segment somehow. Brilliant! There we are. Ah, look! Look at this! Look at this purple thing! It is our house! Beautiful! Let's drop a material on it so we can see it. Boom! That is it. That is the mesh we want. A couple of weird things about it, though. First off, why is it over there? Well, you may have realized that we told it to put all of these walls in exactly the place they are in the world. But the house itself is offset by -7. So what we've ended up doing is we've ended up offsetting everything by -7 and then embedding it in an object and offsetting it by another -7. So what we really need to do is move this house to 0, 0, 0 and have it not rotated. We could do that with matrix math. But do you really want to learn how to do matrix math? Let's give it a shot. Another option is we could actually move it. We could just be like, yeah, house.position equals 0. Duh. Let's try matrix math. Why not, right? It's a fun experiment. Matrix 4x4, our matrix, equals transform.local to world. There we are. And then here we can say filters A, transform.workable minus our matrix. What do you think will happen? Operator minus can't be applied. Oh. Yeah, matrix math is a little bit annoying. I just wanted to show you that. I'm actually going to move it. You can do that math. It's not that hard. If you look inside the matrix, there are a number of functions which can help you. But do you really want to try and learn this stuff? If you do, let me know. I'll teach it to you. But let's be clear. it's super easy to just move the house. Vector 3 old pause equals transform.position, and quaternion old rot equals transform.rotation. Then we say transform.rotation equals quaternion.identity, which is the quaternion equivalent of 0, and transform.position equals vector3.0. Right? Then at the end, we just set them back. Transform.rotation equals old rot, and transform.position equals old pause. Now, I always do it rotation then position, because there is a chance that when you rotate or derotate, it might move your object, depending on where your center of rotation is and how it's interpreting that. So just do the rotation first, just in case, because moving a position will never change the rotation, but moving the rotation might change the position. So do you think that'll fix it? Let's take a quick look. House. Click. Click. It didn't work. What's going on here? Well, the problem here is that we have made a faux pas inside of our house. Is this mesh filter? Here it is. When we search for all mesh filters in our children, we're actually grabbing our own mesh filter. And that means that when we create a mesh, we're going to end up combining it with our own mesh. Well, the easiest way to get rid of that is to say if filters A equals our filter, get component mesh filter, then we want to not do that. So we can say if filters A dot transform equals transform. That's good enough. Then continue, right? That should work. What do you think? Do you think that'll work? Shall we try it out? Actually, we forgot to actually fix it in the first place. This problem is also there, but let's go ahead and fix both of those at the same time. Property or indexer unity component that transform cannot be assigned. I'm full of fat fingers. There we are. Let's see what happens when we click the button now. It works. So here is one of the saving graces of our combiner. It's okay with nulls. You can pass it nulls, and all it does is go, oh, really? Did you mean to pass me a null? Whatever. And it'll throw up this warning. Now, if you really care about that, you can make it so that it doesn't use that. And you can do that by counting the indexes independently, or a number of other ways. We're just going to go ahead and live with the warning because we are doing a tutorial series, and I don't want to spend too long just putting in warning filters. Still, this works. As you can see, we got rid of our shadows, and we are now directly on top. If we were to move all of these wall segments, come on, wall segments. Come on, buddies. There we go. Just move them all. You can see that we have a perfectly good mesh left over. Sounds good to me. We've got it working. This is more or less all you need to do, but we do have an issue here. As you can see from all of this flickering, we have a lot of leftovers. All of these wall segments are left over. We've got, like, stuff here. So what do we want to do? Well, why don't we just go ahead and allow ourselves to hide all of those children. So for int a equals 0, a is less than transform.child count, a++, transform.child, get child, get child the best? Yeah, I guess child. A dot game object dot is set active false. So all we're saying is set all of our children to false. We do not want to worry about them anymore. But this doesn't delete them, it just sets them to false. Boom. No more Z fighting, and all of the children are still here. If you want to do more editing, turn them back on. No problem. Simple, clean, works pretty well for, 8 lines of code. There are a couple of small issues with this. First off, this mesh here is actually quite hard to access. You can't really get at it very easily. It's not exactly saved as a file on your hard drive in any kind of meaningful way that you you can access it or anything like that. But it will survive saves and loads, and you can just leave it there. If you actually need to export it, you'll have to do something a little more complicated. Another thing you might want to consider is these here, we've turned them off, so they're very, very lightweight. But if you wanted to really save absolutely every ounce, once you're done with all of your editing options, you can delete all of these children, and that will make it as light and as fast as possible. Another thing to consider is collision meshes. Did you put collision meshes in these kids? Maybe you just have to turn off the mesh filters and not like all of the children. You can turn the mesh filters off independently of the children if you'd like. But you're not going to want to turn off the mesh filters. You're going to want to turn off the mesh renderers. Really, it's obnoxious. My favorite way to do it is this. You just go ahead and turn off all of the children. Works great. Now, if all of your meshes had the same material, guess what? You have done it. You are done. But, well, that's not what happens for us. We have a couple of small differences here. We actually have two materials. We have a paper material and we have a wood material. Now, one thing we could do is we could set this up with submeshes. Another thing we could do is we could just combine it into two distinct meshes. We could also just leave the windows uncombined, which would be what we would do if the windows could be opened, for example. It would be a good excuse to uncombine them. I'm not going to bother. If you have that kind of situation, we can discuss that, and we can do whatever we want. But it has been a good 20 minutes, and I don't think any of you want to listen anymore. I've taught you the basics. I think that this is good enough for you. It's not a very long function. Let's go over it one more time for posterity's sake. Save the old position and rotation of the house, and then set the position and rotation of the house to 0. Set the rotation first, because sometimes changing the rotation changes the position. So that puts our house at 0, 0, 0. And that means that the world position of all of our stuff is now correct. Got it? So when we move the house to 0, 0, 0, we don't have to worry about it being offset by however far away from 0, 0, 0 the house was. Then we get all of the mesh filters, because those have our meshes in them. Then we put in a bit of a log just for kicks. Now we create a mesh for our final mesh. We create an empty mesh object that we're going to combine into. We create all of the combine instances we're going to need. We create the array, and it's the same length as our filters. We go through all of our filters. We make sure not to include ourselves, because if we've done this before, we have a mesh, and we don't want to write our mesh into our mesh again. It'll just make it denser and denser and denser. So we skip ourselves, but everyone else gets added into the combiners with the submesh of 0, and presumably you're not using submeshes. If you are, you'll have to dance with that some. We select the mesh, remember to use shared mesh, and we make sure to set our transform equal to the world position. Local to world matrix gets the world position and rotation of every mesh. And then we combine it. Then we set it into our shared mesh so that we can actually see it. We set our house back to the old rotation and position, so it's back wherever we put it in our level. And then we turn off all of our children so that we don't have a lot of random flashy lights and Z-fighting. And you can just hit play at this point. I mean, this is now as light as it's going to get. If we regenerate it, click, take a look. This is the only mesh we're going to see. 4,200 tries, 8,000 verts. That's not too bad. It's vert heavy because of the way we're doing it, but that's fine. And we hit play. Works fine. No problems. I can't do anything because I'm just a camera, not a character. But we're ready to rumble. I hope you enjoyed this. Let me know if you have any questions. And that's that.